friction force. And so our learning target is I will explore how net forces affect the motion of objects in one dimension and apply this understanding to analyze situations in real world context, such as vehicle acceleration, conveyor systems, and sports. Okay, so as this is a continuation of net force, really what we're talking about is one specific type of force that can be found in net force. Okay, so the friction force is a force that resists the motion of objects. Okay, the friction force can cause an object to resist the movement, meaning it won't move. It can slow the movement of the object. It could make it roll, or it could slow the motion in the air or water. Okay, so friction is measured in units of newtons, so it's a force. It's just like any other force. The difference is that it's a special type of force. Friction force comes in two types. You have static friction. Okay, static friction keeps objects from moving. So when you push on a box and it doesn't move, right? That's static friction. So the friction pushing against the box is bigger than the push that you're giving it. Okay. Kinetic friction is the force that's resistant to the motion of the object. So it's always in the opposite direction of the motion. Okay. And it shows as a vector that is pointing in the opposite direction of the motion. Okay. So if we're applying the force in the rightward direction, then the friction, whether it's static or kinetic, would be in the leftward direction. Okay, so friction is always opposite direction of the motion. Okay, so if I look at this particular diagram, this free body diagram, basically what it shows me is I have an object that's sitting on a table, right? It's not floating away and it's not going through the table, so it's just kind of sitting there. And that it had an initial push of some sort, right? So it's actually moving, but it's slowing down, right? So if the motion is going to the left, the friction is going to the right. Okay? Basically, this is saying that whatever direction that the object is moving, the friction goes the other way. So yes, it is possible to have positive friction. Okay? So as an example, to find the magnitude, right, how big the friction force is, you can use net force to calculate it. So let's say we have a 20 kilogram crate and it's being pushed to the left, and that force that's being applied is 40 newtons of force. The box moves with an acceleration of 2 meters per second per second. How much friction acts on the crate? Okay, so we're given that the applied force is 40 newtons to the left, okay, and that the acceleration is 2 meters per second per second. We don't know the friction force, okay? So we know the sum of the forces is equal to mass times acceleration. Our forces are the applied force and the friction force. So I have the applied force is going to the left, so that's negative, and the friction force is going to the right, which is positive. Add those together, that's your add up all the forces and set it equal to mass times acceleration. Okay, so then we're going to substitute the number for the applied force, which is 40. So we have negative 40 plus the frictional force is equal to, and then substitute the mass and the acceleration, 20 times 2. And so our frictional force then becomes 40 plus 40, which is 80 newtons. Okay, so to sum it up, friction is a force that resists the motion of objects. Friction is measured in units of newtons. Static friction keeps objects from moving. Kinetic friction slows the motion down. And the magnitude of the friction force can be determined by using net force to calculate it.